Okay, next in our notes is magnitude of heat flow. We're going to look at joules again. This is the standard industrial standard unit of heat. A calorie is 4.184 joules, or a kilocalorie is 4.184 kilojoules. Heat capacity. Okay, heat capacity is the amount of heat required to raise the temperature of the system by 1 degree Celsius. Okay, heat flow equals heat capacity times the change in temperature. So Q equals C times delta T. Remember that the triangle means final minus initial. Heat capacity is capital C. Okay, and we're going to look at something called specific heat, lowercase c, the amount of heat required to raise the temperature of 1 gram. So that's the difference, 1 gram of substance by 1 degree Celsius. Units for specific heat are joules over grams times degrees Celsius. You wrote this on your card. Specific heat for water is 4.18 joules per grams degrees Celsius. And this formula we wrote, Q equals mass times specific heat times delta T. Again, that's heat, or Q equals mass times specific heat times delta T. These are time symbols, not X's. Temperature conversions, those will be necessary. Write these on your card. I will give these to you. You shouldn't need to do any temperature conversions in a test or a quiz, but maybe in a homework assignment. So you're going to plug in your degrees Celsius or plug in degrees Fahrenheit to solve for the other. All right, so these things are card worthy. Again, things I'm not going to give you, but things that might be helpful to write down. So Q equals mass times specific heat times change in temperature. Remember, delta T is TF minus TI. It really doesn't matter if it's T is capital or lowercase. If it says the temperature's increased by, so if the word problem says temperature's increased by, then you're going to have a positive delta T. Think of it like this. Temperature increases from 10 to 90, so this is an increase by temperature. Then if I did TF minus TI, right, I'd get a positive 80. If it tells you the temperature's decreased by a certain amount, then your delta T will be negative. Your change in temperature will be negative. Think of it in this way. If it decreases from 80 to 40, when I do my TF minus TI, I'm going to negative 40. Okay, so now we have a third formula to use. We've already dealt with these two. Now we have this one, Q equals M times C times delta T. And we're going to begin looking at some examples. Okay, as I look at this problem, I see a TI and a TF because it's going from this temperature to this temperature. Okay, and I see, that's all I see, and it's asking for heat, so it's asking for Q. All right, so I have a change in temperature, so we're going to have to use Q equals M times C times delta T. All right, so we're looking for Q. We know our mass. We don't have our mass. We know it's water, so we can use the specific heat of water. So let's go back and look at that, or you can look on your formula page for that. So it's 4.18 joules per grams degrees Celsius. Okay, so I see a delta T, so we can plug that in. Here we're going to say TF, so 10.00 degrees Celsius minus 100.0 degrees Celsius. We know specific heat is 4.18 joules over grams degrees Celsius. And we have to figure out, we're looking for Q, so we must have mass. Okay, so we need to think about mass. We know we have 1 mole, that's a quantity, right? 1 mole of H2O, liquid water. We can get to grams, can't we? Because we know 1 mole of H2O equals 18.02 grams of H2O, periodic table number. So moles of water cancel. So now we know we have 18.02 grams of water. So, making that a little bit cleaner because I got kind of squished there. We have 18.02 grams, that's the mass, times 4.18 joules per grams degrees Celsius. That's how you'd write that unit. Then we have, 10.00 degrees Celsius minus 100.0 degrees Celsius. So we can do this math. Look what happens. Grams cancel. And then when I subtract these two, it'll be 18.02 times 4.18 joules over degrees Celsius. And this subtracting these is going to be 90 degrees Celsius, right? Now I'm going to multiply these. So when I multiply them, I'm going to get a new numeric, but I'm also going to cancel degrees Celsius. So we're going to take 18.02 times 4.18 times negative 90. You could have also punched that all into a calculator at once, and you are going to get negative 6,780, because of sig figs, joules of work or heat. Joules of heat. So if you would have probably gotten your calculator 677.9.12, but this is proper sig figs. Don't worry about proper sig figs, just wanted to make sure I mentioned it.